So very quickly, you just watched a video on how to compare linear regression to exponential regression. The main takeaway there again is to remember that you must look at their correlation coefficients. We have to look at that R value and see which one is closer to 1 or -1. So when we do that, what we're going to actually practice here is do that just 2 different times. And you're going to want it is all Desmos related again. So I'm going to go ahead and clear out my tables here. We can actually get rid of the third column this time because of the fact that we're not making any predictions. We're just seeing um, what type of regression is best. So for this first one, we'll go ahead and type in our data, 1 all the way through 5. Okay, 1, 2, 3, 4, 5, and 4.1. So 4.1, 8.7, and 19.2. Oh, that didn't work. And 28.6 and 64.7. Then once we've got that, we can already see that our regression mode is already here. Our exponential regression is already here. And you can see that our R value is actually very, very good. Our R value is 0.9954. That's actually quite strong. So I'm already expecting that that one's going to win. But let's just be sure. So we're going to go ahead and type in Y1, squiggle line, MX1 plus B, just to really make sure that we're solid. So you can look at your graph if you want to. You can look at the actual lines. And it's hard to really tell a difference between them right now. But if we look at our R values, so we can change the color here real fast. If we look at the green versus the orange, and we look at our R values, we can make note of the fact that your R value for exponential, like we said, was 0.9954, but your R value for linear was 0.9253. And so we're definitely closer, our R value is definitely closer for exponential. So just make a quick note of that on your notes here, that for exponential, right? For exponential, we were at 0.99 versus linear was at 0.92. So our conclusion then is that the one we're going to go with, we feel is the better option is definitely exponential. Okay, so it's pretty much that self-explanatory, is that if your R value is closer to 1, then that's the stronger one. So if you look at example 2, the only difference about example 2 is the fact that we don't want to type in 2004. You don't need to type in these massive numbers. All you really need to actually type in is the ending date, right? The ending number there. So I'm going to press pause and you do the same and jump into Desmos and type in this new table real quick. So hopefully you've got your table typed in. And what we're going to look at, if you look at the Desmos screen, is on the Desmos screen, we're going to have, let's get that pulled up here. We're going to have our data typed in, but you'll notice instead of 2004, I just typed in 4. Instead of 2005, I just typed in 5. So you don't have to type in the entire year. You can just type the fact that we're starting at 4 and then 5, 6, 7, 8 from there. Data's in. Now we're going to compare our R values. R value for exponential is actually 1. And that just means that this is actually a perfect exponential graph. Really close for linear as well, but still it's closer. The 1 value is perfect. You can't beat perfection. So in this case, again, typing these values in, we can see that exponential is going to be the better option. So this again is exponential. It is the better model to model our data. So the goal here is really just to be able to tell what type of model would be better. That's the goal we're trying to accomplish now.